Hi everyone, welcome to week 4 of the maths refresher. The last couple of weeks we've concentrated on algebra. Now going to move out. One of the things that most students struggle with in their senior years is probabilities, statistics, ratios, that kind of thing. So we're going to go a really comprehensive overview of ratios, fractions and proportions. We're going to start off really basic and work up in difficulty. Hopefully by the end it all sort of ties together. Everyone see the whiteboard around? Harrison, are you meant to be with Eve right now?
Pardon?
Are you meant to be with Eve?
Pardon?
Are you meant to be with Eve now?
No.
Oh, okay, no worries. Everyone see the whiteboard?
Yep.
So if you're going to talk, use the chat. Got my headphones. Get the zone and we can check as much progress as possible. All right. Super simple. What's the ratio of circles to squares? So circles to squares. When we're talking about ratios, it's numbers of one thing versus another. So circles to squares is 3 to 1. Ratio of squares to circles, what would that be? Okay. What about circles to total shapes? So squares to total shapes would be 1 to 4. What would the ratio of circles to total shapes be? Three to 4. Okay, one more question on this and we're going to move forward. I has what is the ratio of circles to triangles to squares? Three, 2. Circles to total shapes. Perfect. how many of these shapes are not triangles in a ratio to the total number of shapes? So the number of shapes that are not triangles to the total number of shapes. So the ratio, what about ratio of numbers that, sorry, the ratio of shapes that are not triangles or squares to total shapes? Okay, so you understand that, it's fairly basic. Okay, so now we're going to look at equivalent fractions. So are the ratios 1 to 3 and 4 to 12 equivalent? So why are they equivalent, Harrison? So why are they equivalent, or how are they equivalent fractions? Well, how did we calculate, sorry, that they were equivalent fractions? Exactly. So Harrison said, because when you multiply both the numbers here by 4, you get that. So they're equivalent. And then Ryan said, yeah, that. So he gets it right as well. Okay. The ratio is 9 to 18 and 1 to 2 equivalent. Hey, Ryan. Sorry. All good. He gets the points as well. So if we times both of these by 9, we get 9 to 18. All right. See if I can trick you with some more complicated ones I could think of. 1 to 2 and 14 to 7. Are they equivalent? Are you sure they're not equivalent? What I should have written was it around the right way. So let's say 7 to 14. Now they're equivalent. Sorry. Yes, very good. Okay, 9 to 15, a couple more of these. You guys have got this. Yep. All right, a couple more. We have 1 to 2 and 2 to 7. So 1 to 2 and 2 to 7, are they equivalent? No, they don't have any common denominators. All right, last one, I'll make it as difficult as I can. Equivalent. Ryan and Harrison in the chat, give me your best explanation of what an equivalent fraction is. Or how we calculate it. So that is not an equivalent fraction. My explanation is they need to multiply or divide by a common factor between the two. So now we know how to identify an equivalent ratio. Now I want you guys to write them down. I want you to make a 1 to 9 ratio out of, so complete this ratio if it's 1 to 9. What's the number there? So Harrison says 5 to 45, so it is Ryan. So easy way when you're doing equivalent fractions, just times this number by that. Okay. 1 to 8. Six. What do we got here? Six to 48. Perfect. All right, let's make it a bit more complicated. Okay, so switch it around now. 1 to 2. What number is to 24? That 1 is to 2. So to find this number, we times it by this one. To find this number, we divide 24 by 2, gives us 12. All right. Pressure's on now. Let's go a bit more. So, ratio of 2 to 5. what would the number coming after 6 be? So Harrison says 6 to 50. So we divide this number by 2, which gives us 3. 3 times 5 is 50, which makes sense if we look at the number of 3. That was a bit more complicated, that one. What do we got here? The Harrison says 32 to 4. So if we get rid of this, we divide 32 by this number, by 4. That gives us 8. We take 8, times it by 5. That gives us 32 to 4. All right. Seven to 1 is our equivalent ratio. And we have, and I'll show you my cheater way to figure this out. So easy way to figure this out is just times 5 by 7 gives us 35. Right, one more of these, then we will move on to more complicated stuff. Okay. 2 to 4 and 24. Use my cheating trick again. Hopefully, gives you the right answer. So 24 divided by 2 is 12 times 4 gives us 48. So the ratio is then 24 to 48. Right, one more. I know I keep saying that. Here is slightly more tricky. So the equivalent ratio is 32 to 24. I want to find out. Complete that ratio for me. Okay. So again, using my cheat away, to find out the base number, divide 3 by 24. This gives us 8. So we then divide 32 by 8. Gives us a ratio of 4 to 3. Okay. That's how we write an equivalent ratio. So now we're going to look at worded problems. Or even I'll write them down. 2 seconds, I'm just going to get a piece of tissue paper. Okay. Are these ratios equivalent? Now, don't worry about me trying to trick you. 8 millimeters, 10 days, or 16 millimeters to 20 days. Is that an equivalent ratio? It is. Yeah. So you could say it's a ratio of 2 to 5. Okay. What about this question? So 18 cents to 2 people and 19 cents for every 3 people. Are they equivalent ratios? No? Yeah, you're right. So 18 divided by 2 is 9, 19 divided by 3 is 3.2. So they are not equivalent ratios. All right. If we have 15 cents for every 2 visitors and 16 cents for every 4 visitors, is that equivalent? No? Very good. You can see quite clearly that's not going to be an equivalent fraction. Equivalent ratio. All right. We have, I get paid $4 every 5 hours, or $12, this is about my life, every 13 hours. Am I getting paid equivalent amounts? No, getting stitched up. $4 every 5 hours is 80 cents. $12 every 13. What's 12 divided by 13? That gives us 92 cents. A lot of the time people will say to you, well, this isn't applicable to anything. Well, when am I going to use this in real life? A lot. Most things in maths you will use in your day-to-day life. Someone offers you 2 different rates of pay and you don't know how to figure out which one's different, well, there you go. Lots of people go through life without having the basic groundings in maths, and a lot of the time they get themselves in trouble because of it. Okay, a couple more of these. So one staff member, 10 canvass, and 2 staff per 20 canvass. Equivalent? Yeah. 1 to 10, 2 to 20. 2 to 20 is still 1 to 10. All right, 2 more. Trying to drill these concepts in because they're really important. All right. So 3 strikes for every 2 balls. That doesn't, don't think too hard. So 9 strikes per 6 balls. Are they equivalent? Yes, they are. 3 divided by 3 is 3, 3 divided by 6 is 2. All right, last one. Okay, 16 employees, 2 days, 8 employees, 2 the equivalent. Yeah. Okay, let's move on to what we call proportions. So we're talking about proportions, we're talking about ratios. We need to be able to divide them by a common denominator. So we have 1/2 and 7/40. What we're looking for, are they equal? So it's a ratio of 1/2 the same as 7/40. Harrison says yes. Perfect. So 1/3 and 4/12. Yep, form a proportion. So if I divide by 4, it gives me 1/3. So yes, they are in proportion with each other. Three over 4 and 4 over 1. No, these are not in proportion. There's another way to calculate it is 3/4 is 0.75. 4 over 1 is 4. So they're not the same. They are not in proportion with each other. What if I have 1 over 5 and 3 over 4? No, they're not, because there's no common denominator between the numbers. Okay, 3 more of these questions and we'll move on to some other stuff. As always, time is getting away. 3 over 1 and 18 over 6. So Harrison says yes. If I divide 18 by 6, 6 by 6, I get 3 over 1. So they are in proportion. Second last one, 18 to 12 and 3 to 2. If you're watching the recording, I am going quite quickly today. That's purely just because there's so much to do. I'm trying to keep it to under 45 minutes or so to keep everybody. So yes, so if I divide 18 by 6, 12 by 6, would that give me 3 to 2? All right, last one. 3 over 4 and 2 over 5. Three quarters and 2/5 are not in proportion. So now we're going to mix my two favorite things in the world together. Proportions and algebra. So we have B divided by 3 equals 15 over 10. Anyone that's watching and you guys there, give you 1 minute to calculate what the value of B might be. B equals 5. Correct. So if we sub in B equals 5, then that gives us we can do a couple of these because they're quite tricky. We have what is the value of G? That's not a 9, by the way, that's a G. G equals 50. Very good. All right, let's do one last topic to get through in 5 or 6 minutes. So I'm going to use my screen here. We're going to look at rate of change. And we're going to do that by looking at graphs. So this is the last topic for ratios. Okay, share the screen first. Types. Okay, so we're looking at this graph here. So, according to the graph, what was the rate of change between 2008 and 2011? So 2008, we had 16 rounds. And then in 2011, there was 19. So that's a change of 3. Anyone want to hazard a guess at the answer? So if we have 3 years and the number of rounds per year has increased by 3. How many rounds per year is that? So the number of rounds that have changed has gone from 16 to 19. So that's 3. The number of years is 3, 2008 to 2011. So we've had rate of change of 1 per year. So again, we'll look at this table here. So Harrison or Ryan, what is the rate of change between Sunday and Wednesday in the number of emails written per day? So Sunday, there's 6. Wednesday, there's 9. So 3 emails in 4 days should give us 0.7 or 1 per day, sorry. 6 and 9, there's 3 days, so done. All right. Another good one. I'll give everyone 60 seconds to figure this one out. What was the rate of change in minutes per month between June and July for the average waiting time at this doctor's office? So 30 seconds. So the change, so in June we had 30, and in July we had 45. So there's 15 over 2 months. What's the change per month? So there's 2 months, and the change is 15. So 15 divided by the months of June and July. Oh, okay. No, I do apologize. They're counting that as 1 month. So there we go. I did that wrong because I misinterpreted the question. Now I look really silly. So Harrison, you were right the first time. They're counting June to July as 1 month, whereas I was counting to 2 months. But the idea is that it's the total change versus the total amount of time. I think we'll leave it there today. That's 40 odd minutes of you guys concentrating. Thank you so much, everyone. I'll see you next week. Trying to stick to like 42, 43 minutes because they're getting longer than that and no one concentrates, including me. So I'll see you next week.